Alright everyone, today's talk is going to be pretty unusual by our standards. It's not a technical talk, but rather a talk about a tool I made called PyPresent, which is about pre-recording presentations. Now before I continue, a warning. This talk is about an unholy mixture of me blathering on about video editing, Python, microphone problems, and in general complaining about technology. Do not expect me to give you any elegant theorems in this proof, nor to reprove them elegantly, nor to code up a clever algorithm, or to do anything really groundbreaking. Now that that's out of the way, presentations are hard. Let's suppose someone suffers from any of these issues when giving a live presentation. 1. They have a strange sounding voice. 2. They have bad enunciation. 3. They have low energy. And as a catch-all 4, they're generally poorly comprehensible. As I'm sure you can guess, most of these refer to me. How would one go about mitigating these problems? Or perhaps more accurately, how do I go about mitigating them? Well, I pre-record my talks, just like this one. My voice sounds strange? Great, I can modify it in an audio mixer. I mess up on, I can redo the segment. Giving the talk is too tiring? No problem. Now I can just hit play. It really does work out quite well. So how do you give a pre-recorded talk? What is the easiest way to actually pre-record things? Now, I'll be the first to report that the most obvious solutions to the pre-recording problem don't really work. The most commonly heard suggestion is to use PowerPoint, and in its defense, it's a very capable program that will let me insert any audio I want into the slides and sync the slides accordingly. However, A, it's expensive, and B, it's not cross-platform. The second one in particular is a real issue. If you spend a lot of your time, like I do, on a Linux machine, then it's just not really an effective option. Once PowerPoint is out of the picture, the next obvious idea is to use a camera to give the talk beforehand and just film it. Unfortunately, this doesn't really work if you are at all prone to making mistakes, like I am. Basically, if you make a mistake, you will restart from the top. Now, there are a few more drastic solutions, and they're even less effective. One I've heard is to dictate my talk to someone else, to an actor. However, most computer scientists have no interest in directing, and in general this approach is just a lot of hassle for very little gain. Beyond that, you get even more out there ideas. My favorite one was one I heard on the internet. They suggested to not pre-record it at all, and instead give it in a format more amenable to the restrictions listed at the beginning. And they suggested, in full seriousness, to give the talk using Morse code. All I say to that is, Did you understand that? Neither did I. However, we're all computer scientists. We're not ones to let this discourage us. There are some ways to pre-record talks. Let's look at the current method. Step 1, make the slides. As I mentioned before, I primarily use Linux, and that means that the way to make slides is to use LaTeX and Beamer. LaTeX, of course, is the ubiquitous typesetting system, and Beamer is a hack of a hack of a hack of LaTeX used to turn that typesetting into PDF slides. It's a very powerful system. It's also mind-numbingly boring to work on, but we'll sidestep that issue for the moment. Step 2 is to record with OBS. OBS is a screen capture system primarily aimed at video game streamers. Hopefully you've all seen these at least once, but they're very powerful programs that use screen capture anything and also record your audio. Everything gets outputted into a nice MP4 file, and recording is as simple as pressing a button. The only tricky point is that you have to record in small chunks. This isn't a restriction from OBS, but rather a restriction enforced by you, the recorder, so if you make a mistake, you don't have to start from the beginning. Now, once you have all those recording chunks done, you go to step 3, stitch them together. To do that, use the video editing program of your choice. If you're on Linux, good options include KDE and Live, which is what I use. It's a very simple non-linear editor. Another option is to use Blender, which is incredibly difficult, but again incredibly capable. Both are free, both are pretty easy. The hard part is once you've stitched everything together, you have to go to step 4, render your presentation. In KDE Live, there's a very nice render button. You click it, you choose your settings, and then, once you've got everything set up, you wait, and wait, and wait. In fact, you wait so much that you develop an entire agenda for how you spend your time waiting. Some common do's on that agenda are to binge watch a long TV series. In my experience, you can get through the entire 10-season run of X-Files in about a third of the time it takes to render a 20-minute talk. Once you've completed that, read a massive book. I do not mean a somewhat long book. I mean literally break out a dictionary and read it cover to cover. This will probably take you up to 3/4 of the way through the rendering. Once you're done with that, play a never-ending game. In my experience, some good standbys are the Civilization series, or if you prefer a more realistic game, any of the Paradox Grand Strategy games. This will not take as long as the TV series or the book, but it should round out the render time. If you finish before the render is complete, return to step 1 of binge watching its TV series. During this time, do not ever try to do anything productive. The moment you think, oh, I can work on that project, the render will crash and you'll have to start all over again. Assuming you made it to the end of the render without going crazy, you proceed to Step 5. Realize you made a mistake and return to recording in Step 2. This will happen. Enjoy. Once you've completed Steps 2 through 5, enough that you no longer care about the mistakes you've made, you finally get to Step 6. Upload the video. Thank God it's over with. Now, it doesn't take a PhD to realize that workflow sucks. The big issue is with the editing. It's a major time bottleneck. It takes a while to render and such, and in general necessitates a bunch of restarts. This is largely because video editors are complex, robust pieces of software. They're designed to handle any type of video you can throw at them and apply any effect you want in any manner whatsoever. Efficiency isn't the issue so much as capability, and we simply don't need that capability. We just need to sync some sound files to some still images. It's not too hard of a task. So, with that in mind, we made our own system to do just that, PyPresent. And it consists of 3 utilities. Makeslides, which bundles a bunch of slides you made together, pretty self-explanatory. Recslides, which records your presentation, again, pretty self-explanatory. And finally, playslides, which plays things back. No problem whatsoever. This gives us an entirely different workflow, which is a bit easier to use, at least in theory. The first step is Step 0. Sell your soul to the devil, known as Python. Put in less apocalyptic terms, get your dependencies in order. PyPresent, as you could probably guess from the name, is just a series of Python scripts. Now, I know since we're in optimization, that may want to make you leave the room immediately. I ask that you bear with me because it's very simple. There are only 3 real dependencies, 3 simple modules. One is wand, which is an image manipulation module. It works by wrapping the image magic program. Image magic is a utility for resizing, converting, and in general manipulating images. The main reason we use it is it can manipulate PDFs as well. Once we have one set up, we're going to need Pygame for the actual playback and control. Now, Pygame, as its name suggests, is a game development library for Python, so it's a bit heavier than what we need, but it works pretty well, and it's really easy to use. And once we have Pygame ready, we need PyAudio, which, as the name implies, is a Python audio library, and we'll use it for recording. So, get all those up and running. Now, we can proceed to a very familiar step. Step 1, make the slides. Really, we can't avoid this step. As much as we'd like to, PyPresent can't write slides for you. Although that might be an interesting NLP exercise, to write a program that takes an academic paper and produces beam slides. But putting that aside, making slides is still somewhat easier than before in that we don't need to rely on just LaTeX and Beamer. We can copy our slides together from anything: PDF files, PNG files, GIF files, and JPEG files, or really any image file for that matter. If image files can handle it, we can use it. We don't even have to keep the order straight at this point. So, once we've got our slides made, step 2, run the makeslides utility begins. And makeslides, as we mentioned, bundles our slides together. The way it works is that we call it by running Python makeslides.py. Hopefully you can figure that out on your own. Once we've done that, it'll prompt us to name our presentation. So give it some name, doesn't really matter. And then we can add slides to that presentation in the following manner. We type load file name start page, end page. Start page and end page are optional, but it works the same way. It loads pages start page to end page of file name into the presentation. By default, start page is 1. If we specify it, end page is the same if unspecified. And if we specify neither, it's the entire file. Fairly simple. And once we've added our files in, we type quit. If we name the presentation name, everything is saved in name.zip. This all works, as I said, with the run library. Here's an example of its usage directly from makeslides. This is the function that takes a file and converts it to the PNG files that we internally use. So we use run.image.image to load the file at a resolution of 300 dpi. We make it so high so everything is sufficiently large. We'd rather be downscaling than upscaling. Assuming that all goes well, we iterate through the pages which we access through this sequence field of image file. We can load each page from that sequence into a PNG file. We remove any background transparency and we save it. Pretty simple, right? But once we're done with this, we proceed to step 3, run the recslides utility. As we mentioned, recslides is the recording utility of PyPresent. We run it the same way as makeslides, just a Python call, nothing complicated there. And we enter the name as before. Once we've done that, we can use K to toggle recording. By default, it's not recording. And we can advance through the slides by pressing J or L to go backwards or forwards. And when we're done, we can press Q to quit. If we named it name, everything is going to be saved in namerec.zip. Namerec.zip will have 2 things in it: an assets zip file, which will contain all the images and sound files, and a file, pres.txt, which is the log of everything we did. Now, the code for recslides is quite a bit more complicated than the code for makeslides. The code is a giant run loop. It's supposed to run at 60 frames per second. though for reasons we'll see it doesn't. And this here is just a bit of code to navigate through the slides. We pull the events from Pygame, and if there is a necessary key down event, we advance the slides as necessary. And if we change the slides, we simply set a new slide and add that to the log. Very simple. Now, the recording toggle is similarly a part of the game loop. This whole segment is. The main difference is that we're adding two variables, code time and old time, which are real-time variables. And we use them to record how long we've been listening. And when we press K, if we've toggled it to pause, we write everything we have. And if we're toggling it to unpause to record, then we get the effective frame we're on from total time, which is another variable we added for real-time control. And we measure a corresponding new name for our WAV file. The WAV file, of course, is the file we record the sound in. Now, the logging control also happens within the game loop, and it happens after we've pulled all the events. On every iteration, we read a chunk of sound from a screen variable. That's the reason why this doesn't run at 60 frames per second. It's the reason we need those real-time variables, code time and old time. If we didn't need them, if this read at 60 frames per second properly, we could just keep track of what frame we're on. However, it was difficult, but we've worked around that with this hack. And then at the end of each iteration, we take all of the commands we've done in that loop and we add them to this F string, FSCR. And when we're done, we write everything in FSCR to a log file, which looks like this. It includes the frame number, allows the effective frame number, and what we did then. Simple, but effective. The next step, step 4, is by far the simplest. We run the playslides utility. As we mentioned, this plays back the recording. We invoke it the same way as always, and that's it. After we enter the presentation's name, assuming it can find namerec.zip, it runs automatically. Everything happens again in the game loop. However, it's a lot simpler than before. All we do is make sure we haven't quit the program, and then we execute the commands from the corresponding frame. Now, it's important that we maintain 60 frames per second, otherwise things crash and burn and desync, but that's usually not an issue. Now, the execute command at the bottom, the one that actually runs things from the log, is also very simple. We just check to see what we're doing. If it's a slide command, we set the corresponding slide. If it's a play command, we play the corresponding sound. And if it's an end command, we stop playback. Nice, no real issues. Unfortunately, PyPresent has some drawbacks. In fact, it has several drawbacks. Now, this is to be expected, as PyPresent is basically a glorified beta right now. However, they're pretty severe. First off, there's no ability to edit whatsoever. Once you're done recording, that's it. So, if you stutter over something, if you bite your tongue, or if you otherwise flub your arm, you're going to have to restart. This naturally slows things down to a snail's pace, as we're basically doing what the original down suggestion of using a camera was doing. However, assuming you do get through recording, there's also another issue, which is that Pi audio is rather finicky. In my experience, it doesn't always find your microphone. In fact, it very rarely finds your microphone. As such, you're going to have to hunt down the device ID of your microphone and manually input it into the source code. Not exactly a user-friendly method, but once you've had that done, you also have to avoid running this on an Apple computer. This is because Pygame, and in particular the SDL library beneath Pygame, hates the new Retina displays that MacBooks have. Remember how I said usually it's no issue to run at 60 frames per second? Well, on a MacBook it is an issue. You're going to be going at closer to 12 frames per second. Also, the images may appear somewhat corrupted, so as a result, everything's going to desync horribly. And even assuming you've avoided all of these issues, there is the fact that you can't export this to a video. You have to play back with playslides.py. This is an inherent issue with Pygame. There's just not an easy record method. Theoretically, you could get around it by using OBS and their window capture software, but then we have to use the video editor again, which is not ideal. There are some ways around this, and we will be investigating them, but not in the immediate future. However, that being said, we're not stopping development of PyPresent at all. It is a beta right now, and over its development we do hope to address most of these issues. Naturally, we want to make an editing utility because of the simple text format of the pres.txt file. This should be fairly straightforward to do from the back end. The only difficulty will be getting a nice user interface for the editor. Once we've done that, we're going to replace Pi audio with something less error-prone. This is, we know, possible. After all, programs like Skype and OBS automatically detect the microphone. There is a way to do it, we just don't know how. Also, if possible, maybe we'll find a method where the recording runs at faster than 10 frames a second. Once we've got that done, we'd like to change to C++. This should not come as a surprise. We're all in optimization, and we all know that Python is pure evil. And once we're done with all of that, I should probably look into that Apple issue. Maybe. I didn't use an Apple, so it's not really a priority of mine. Now, if you want to follow these developments, the code or the monstrosity that's masquerading as a code is available at this GitHub repo. Now, we do intend to continue development and outside of PyPresent scope as well to address some of those issues with giving a presentation, primarily comprehensibility and weird speech. These would be tools to manipulate the voice pitch and to transcribe things to text. However, that's outside the PyPresent scope and the talk for another time. So, with that, thank you. Are there any questions?